Well, welcome to forecasting using time series methods in business analytics. Well, forecasting is an essential element to operating a business, and it's an attempt really to predict the future. And what we're trying to predict are how many widgets we're going to sell or what the demand is going to be for our product or services. We need to know that so that we know how many to produce, how many people to hire, how much warehouse space we need. Now, within forecasting, there are two broad ranges. There's qualitative and there's quantitative. Qualitative are subjective methods where I'm just going to guess, and a lot of small businesses will use this, usually to their detriment. Quantitative forecasts, of course, because this is a business analytics course, we'll be focusing on that, but that's going to be based on mathematical formulas, and they're going to be, as you might guess, far more accurate. As I mentioned, in this lesson, we're going to be talking about quantitative methods. We're also going to be focusing on a forecasting method called time series analysis. The idea behind time series is that demand is going to be affected by time. It's going to go up or down over time. Now, there's going to be other things that affect that within time, and we'll talk about that as well. There are many different methods that you will encounter either in production operations or business analytics. But again, we're focusing on time series, and we're assuming that what happened in the past will occur in the future, and that the only thing that affects demand or sales is time. Now, obviously, you can probably think to yourself, well, there's probably going to be other things that are going to affect that demand or sales as well. And that's okay, and we'll cover those later in additional business analytics lessons or production operations management lessons here. But the factors that we're going to be talking about, the methods we'll be talking about today are the moving average, exponential smoothing, and the linear trend line or regression. And again, the only factor we're concerned with as affecting demand is going to be time. As I mentioned, the only variable we're really concerned about is time, but we do also understand that even with only time involved, there are some additional factors that may affect the demand or sales of a product or service. For instance, we could have a trend. Maybe we're going up over time or down over time. Seasonality, maybe in the winter we don't sell as much of our product as we'd like to, or cycles, maybe business cycles affect our product as well. We'll be talking about these a little bit more as we continue on. Here we see a chart that illustrates a trend pattern. This is the U.S. home prices on average, and notice that overall they're trending upward. They could also trend downwards. They may be linear or nonlinear, and they could also change exponentially, which we kind of see with one of the years during COVID. All right, so we'll discuss these a little bit more as we continue on. Here you see a chart of demand or sales that are affected by seasonality. Notice that we have ups and downs during different quarters or seasons of the year. Now notice though that even with the seasonality effect, we still are trending up over time. So we can still use time series analysis even if our product is affected seasonally. Here we have a product or service whose demand or sales is affected by business cycles. Business cycles occur normally within 7 to 10 year ranges, and perhaps we have a product that is a luxury product that is affected severely by business cycles. Okay, with that introduction, it's time to actually get into some specific methods, and the methods that we're going to be talking about are the moving average, using exponential smoothing, and doing forecasting with linear trend line or regression. One of the simplest mathematical time series forecasts to do is the moving average. And within the moving average, we have a naive forecast and a simple moving average. Now, with a naive forecast that we'll discuss here a little bit more in detail, we simply base the prediction of the current month's demand on the past month. So we just look at essentially an average of 1 month. We also have a simple moving average where we can take a fixed sequence of periods, such as every 3 months, we average those out, or every 5 months. And we'll go ahead and see how these work in the next slide here. Here's an example of a naive forecast. With a naive forecast, we just take the previous month's sales or demand and make that the forecast for the next month. So in this case, we sold 120 widgets in January, and so therefore we are going to predict or forecast that we'll sell that many in February. We only sold 90 in February, so we're going to forecast for March 90. And you can see that potentially there are some errors that occur here, and we're going to be talking about forecasting error here as we continue and how to actually measure forecasting error. But naive forecast, it's a method. It is a moving average, but it's not the best method. That we have some better methods that we'll talk about. Well, now we're going to go ahead and talk about a simple moving average of a 3-month moving average. So in this case, we just are going to take the previous 3 months demands or sales, we're going to average those, and that becomes the forecast for the next month. That helps smooth out some of the errors that we saw with a naive forecast. And there you have the official formula. You sum up the demand for the number of periods, in this case 3, you divide by 3, and you create a very simple moving average. All right, so here we see the 3-month moving average in action. So we take the previous 3 months, so in this case January was 120, February was 90, March was 125, we average that out, and then that gives us a forecast for April of 97. We include that 75 actual in the 3-month average. This time we're moving along with February, March, and April. We end up with a uh, prediction or a forecast for May of 100. So you can see this might be a little bit more accurate than the naive forecast. And again, we're going to learn how to measure the error here in just a second. Right here we see a chart of the 3-month moving average example that we just showed on the previous slide, and notice that the actual forecasts are a little smoother than they would be if we just took month by month. And the purpose of this is just to help us schedule things a little bit better, so that we're not ordering a whole bunch this month and not this month, and so on. And so the 3-month moving average and some of the other methods we're going to be showing help us do that, help us smooth out our forecasts a little bit. Well, I keep discussing forecasting error and the fact that our forecasts are not exactly correct. And we do want to measure, we are concerned about the forecasting error. And so the way we compute the forecasting error is simply the actual and we subtract the forecast. So in this case, with a 3-month moving average, April had a forecast of 97, but our actual demand or sales for April was 75. And so our forecast error is negative 22. For May, we sold 99, but we predicted or forecasted we would sell 100, so we have a negative 1, and so on and so forth. And so we're going to be doing a little bit more with this forecasting error, but the forecasting error is simply the actual less the forecast. Two other computations we're going to be talking about in dealing with forecasting error are the MAD, the mean absolute deviation, which just sums up the absolute values of the error and divides it by how many months you forecasted, or I said months, but I meant time periods. It could be week, it could be day, it could be year. We also have the mean absolute percent error. That's where we're summing up the percentage of the error and again dividing it by the number of time periods. And we'll go over these computations in the next slide. All right, here we've computed both the MAD and the MAPE. Let's talk about the MAD, the mean absolute deviation, first. All right, so we have the forecast error column that I've added here, again with this simple illustration using widget sales. And so our forecast error for April was negative 22. We need, in order to compute the mean absolute, hence the word absolute, the absolute value of the error. So in this column here we have the ABS error. I've used Excel's absolute function, and so we end up with, and I have rounded them in the forecasting error, and I actually have taken it to 2 digits here. We see 21.67 as the absolute value. The next step in computing the MAD is to sum the error. So I've summed the error down here. We have 117.33. We divide it by the number of forecasts that we have computed an error for, which in this case is just April, May, June, July, August, September, and October. We don't have the values for November yet with this example. So we're dividing it by 7, and we end up then with a mean absolute deviation of 16.76 widgets. All right, we can also compute the percentage error, and we take the percentage of the error. So we compute the percentage. In other words, what is the percentage of error between the 22 and the 75 that we sold? We ended up with 28.89% for April, a very small percentage for May, and so on. So then we sum up the percentages. We end up with 140% error altogether in sum, but again we divide that by the number of time periods in the forecast, which is 7. So we end up with a mean absolute percentage error of 20.1%. They're very simple formulas, but they're very important in telling us how accurate our forecasting methods are. All right, let's discuss exponential smoothing. Exponential smoothing is a very widely used and very accurate method in using time series forecast. And again, what good is a forecast if it isn't accurate? And so one of the ways that this is a little bit more accurate is we add a weight to more recent data, and it's called a smoothing constant. So the formula to compute a forecast, so the forecast for time period plus 1, in other words, time period 2, is going to be the smoothing constant, and that's a value between 0 and 1. And the higher or the closer it is to 1, the higher the value, the more weight it puts on more recent data. And then we're going to add to that. Okay, so it's the smoothing factor times the observed for the period above. In other words, for period 1, if we're forecasting period 2. So the forecast for period 2 is the exponential smoothing factor times the actual for period 1 plus 1 minus the forecast for that period. All right, it seems a little bit confusing, but it's actually fairly simple, and I'll show you in the next slide how we actually compute forecasts based on exponential smoothing. All right, you're looking at a lot of numbers on the screen here, but let me see if I can make this as simple as possible here. Notice up in the top right of the chart, I have a smoothing factor of 0.3. And because that is less than zero point 0.5, I'm putting more value on the older data than I am the current data. Okay, so the way it works here in this case, we have January and we sold 120 in January. Now our forecast is 120 because we can't do a smoothing forecast yet with the first month. So we just put in 120, the actual demand for the first forecast. Okay, then we go ahead and we'll work down to March just so, because that's the example that I have here. Okay, so for March, we have zero point 0.3, which is the exponential smoothing factor, the smoothing constant, times the actual in February, which is 90, plus zero point 0.7, which is 1 minus the smoothing factor of the February forecast. So the February forecast was 120 because we just copied the one above it for January. We then end up with a forecast for March of 111. Okay, so now let's just talk a little bit about some of the other things we're seeing here. We have a forecast error because that's still important to us. The forecast error for March is 14. We predicted that we would sell 111 and we only sold, or we did sell 125. Then of course to do the MAD, we take the absolute error, we sum it up, divide it by the number of time periods we have a forecast for, which in this case is 9. We are able to compute more months, the earlier months, using the smoothing example here. Okay, then we have the absolute error. So again, we have the smoothing factor and we include that in computing the forecast. So the forecast becomes the smoothing constant times the actual for the month above it plus 0.7 or 1 minus the smoothing constant for the prediction or the forecast for that month. Really not that bad once you get the hang of it. Here we see a chart of the exponentially smooth forecast, and notice that it's becoming a little smoother than what we had, obviously, than we had for the naive forecast, a little smoother than we had for the 3-month moving average. And again, smoothing helps us in forecasting so that we're not constantly hiring and firing or ramping up production and cutting off production and laying off people. The smoothing forecast helps us know over time where we're going to be. All right, another method that we have with time series is regression analysis. And in order to properly use regression analysis, we really need to have a trend that is linear. We could be increasing or decreasing over time, but if our trend is not linear, then we need to find another method for time series analysis here. But if it is, and you could start with a graph of your 3-month moving average or the exponential smoothing, and you can kind of get an idea of if a trend line will fit that. And if it will, then regression analysis is a great way to do forecasting. And we'll go ahead and discuss that in the next slide. Well, here are values in a chart for the December 31st close of the Dow Jones Industrial Averages for the last 20 years. And so I've charted them out, and then I actually had Excel apply a trend line, and I can see that yes, that there is definitely a linear trend here. So this is a perfect example of when I can use regression as a forecast. And we'll go ahead and step through that in the next slide. All right, so I've run those numbers in Excel, running the regression. And remember, when you do regression, you have both a dependent and independent variables. In this case, the dependent variable is the close. We only have one independent variable, and that is time, in this case, years. So we've run through the regression. We have an intercept, and we have the slope for the x variable. And so using the intercept and the slope, we can then go ahead and compute a forecast. So in the next slide, I'm going to show you how we actually forecast using this regression model, and we'll see how accurate it is. And so here I've used my regression equation to forecast the close for each year, and we can see that we do have some errors, but when we do an absolute error and we compute the mean absolute deviation, we only have a mean absolute deviation of 2,628.89. And so it appears that this is a fairly accurate way to predict or forecast the close of the Dow Jones using only time as a variable. Okay, that concludes this brief introduction to time series forecasting and introduction to business analytics. Hopefully you found this helpful. If you did, please consider liking this video and consider subscribing to my channel. Remember, there's always many other additional videos and resources on my website, luthermaddy.com. Thank you very much, and we'll see you in the next video.